Okay, moving on to Sutra 12 or lesson 12 of the Vedic Mathematics. Uh, Once again, a long name. It's pronounced as Shesanyankena Charamena. Shesanyankena Charamena. So, what's the translation? English is the remainders by the last digit. The remainders by the last digit. So, this sutra provides again a unique method for division, particularly by checking the accuracy of the remainder and for converting fractions to their decimal form. Okay. So, in authentic Vedic maths, this sutra reveals a profound understanding of the relationship between remainders and divisibility. Right? The Sanskrit term shesha refers to what remains or what is left over, shesha, while charamena refers to the final or the last element. So, this principle recognizes that remainder follows systematic patterns that can be used to verify calculations and extend division into decimal expansions. So, the ancient sages understood that by tracking remainders through each step of division, one could develop efficient method for both mental calculations and verifications, demonstrating their deep understanding of number properties and divisibility. Okay, so let's look at the first example, which is division with remainders. Right. So the number is 1, 2, 3, 4. So 1234 divided by 7. Okay. So step one is basically start dividing using remainder method, right? So you basically start, as it's a single digit, you start from the first one, right? So the Vedic approach to division with remainders demonstrate that elegant efficiency of ancient mathematical thinking. So rather than using conventional long division method, the Vedic sages developed a technique that processes each digit while carrying forward the reminders. Very different, right? Each digit you divide from left to right and then carry forward the reminder. So this method reveals the systematic nature of reminders and provides a natural verification mechanism. By tracking how reminders propagate through the calculations, we gain deeper insight into the divisibility properties of numbers and develop a more intuitive understanding of the division process. Okay, so the divisor is 7, the dividend is 1234, right? So now we start from left to right. So step one is the first number, in our problem here is 1. So 1 divided by 7, right? So if you divide 1 by 7, right, so the remainder is 1, right, because it's not divisible. So you put 1 divided by 7, 0, and the remainder is 1. So you carry your 1 to the second one, so that is 1 and 2, 12. So 12 divided by 7, 1 times, and you have 5 remainder, right? So you carry 5 to the next digit, 3, so that's 53 by 7, right? So again, you divide that, and what is the remainder? So it's 49. 7 times 7 is 49. Remainder is 4, right? And then you carry your 4. The last one is 4. So that's 44 by 7 is basically 6. And remainder is 2, right? So it's 42. So it's 44. The remainder is 2. So what's your quotient now? It's 176. 176 is the quotient, and the remainder is 2, right? So that's your answer, right? So divide that, it's 176, 176, right? 176, 176, and the remainder is the last remainder is 2. Okay? So you saw how this division can work. Now you can take the stuff, but you can convert it also into decimal division, right? So here, same process, okay? So 456 divided by 13, right? So the extension of the remainder principle to decimal division reveal the Vedic understanding of infinite series and recurring patterns, right? The ancient sages recognized that when a remainder is encountered, it can be extended into the decimal realm by continuing the division process. Same process, left to right, we can continue, right? So this insight connects the discrete world of whole number division with the continuous world of decimal expansions. So by understanding the relationship between remainders and decimal patterns, the Vedic mathematicians developed methods to identify recurring decimals and predict their behavior, demonstrating their sophisticated understanding of number theory. Right? So now you process digits systematically with remainders, right? So same thing, now it's because it's 13, you take two digits, so 45 divided by 13, right? So it's 3 times, right, 39, and then what happens, 45, right? So the remainder is 6, right? So the first one you take it, so it's the quotient, the first part is 3, remainder is 6, that's 66, so that's 5, right? So 66, so if you do the 5 times, 13s, that's 65, so you have a remainder of 1, right? So your quotient is 35 and your remainder is 1. So you want to verify it, 35 times 13 plus 1 will give you 456, right? So the result is 35 with remainder 1, right? And then you continue it on the right side, so now the answer gets into the decimal. So it's 35, 1 divided by 13, right? Same process, you continue, so that's 0.076, okay? So again, once again, Shesanyankena, Charamena teaches us to pay careful attention to reminders in division. Right? So by tracking reminders systematically, we can perform division efficiently, verify our results, and extend division into decimal representations. So the Vedic insights we have explored reveal that this sutra is not just a computational technique, but a profound understanding of number properties and divisibility. So the ancient sages recognized patterns in remainders that allowed them to develop elegant and efficient methods for division, demonstrating the depth and sophistication of Vedic mathematical thinking.